How does a computer actually sees an image? So basically, your computer doesn't actually see these images. You see a person, a car, maybe a dog, but your computer sees something completely different. It sees numbers. And in this video, we are going to take this image and break it down until you can actually see what the computer sees. So, if you are starting computer vision, this is one of the first thing you need to understand because before a computer can detect a face, recognize an image or object, or classify an image, it first needs an actual numerical representation of that image. So let's start with the simplest question. What is an image to a computer? To us, this looks like one complete image or picture. But if we zoom in far enough, we get tiny units that are called as. So each pixel stores information about the color at that particular location. And when you put thousands or millions of these pixels together, you get the image we see. Now, okay, let's do a quick question take. If I give you one pixel, do you think the computer stores the word red? No, it stores numbers. And that's where RGB comes in. Now, we'll move on towards what's RGB. So, RGB stands for red, green, and blue. A pixel is represented using these three values, one for each of these channels. And each value typically range from 0 to 255. 0 means there is no contribution from the color, while 255 means full intensity. So, if I give you 255 for red and 0 for green and blue, then what do we get? Can you guess? Yes, we will get a pure red. And if all three channels are 255, then think. Yes. Then we'll get a white because all these three colors are put in its full intensity and that's where white is from. Now, what if there are all zero? Like all those color numerical representation are zero. Then we get black. Now, here's where it starts getting a little interesting. We don't just have red, green, and blue because each channel can have values from 0 to 255. We can combine different intensities of those three channels to create millions of different colors. Now, that one colorful image you see on your screen is actually being represented by a huge amount of numerical information. Okay, we are still missing one piece. We know what one pixel looks like numerically, but how do we represent an entire image? We arrange all those pixel values into an array. Example, an RGB image with a height and weight of 224 by 224 can have a shape of 224 into 224 into 3. Here, the first 224 represents the height, the second 224 represents the weight, and the third 3 represents the three color channels that is red, green, and blue. So instead of seeing one images, the computer is working with this entire numerical structure. Now, we'll move on towards a quick challenge, you can say, a quick recap of what we have learned. Let's test whether you actually got it or not. So, if this is the image shape, what does the 3 from this numerical representation represents? Yes, the 3 represents the 3 color channels that are RGB, that means red, green, and blue. Now, one more. If the numerical representation shown on screen, what color is this? Yes, fine. If you got both, you are ready for the next part. And our next part is a problem. But here's the problem. Knowing the numbers isn't enough. If I give a computer this image, how does it figure out where the important information is? And what are the edges and what are the shapes? Which part actually matter? And that's where image filtering and convolution come. This is the foundation of computer vision. Before we get into things like face detection and image classification, we need to understand how images are represented and how useful features can be extracted from them. Once you understand the foundation, the CNNs, this all becomes much easier to understand. So let's quickly recap. Number one, an image is made up of pixels. Number two, in RGB, each pixel contains red, green, blue intensity values that typically changes from 0 to 255. And number three, An RGB image can be represented as a height, weight, and into a three array. Now, in our next video, one new question, that is, how can a computer actually find useful features like edge and patterns from all those pixels? That's exactly what we are going to explore next. And when we get into image filtering and convolution, and that's where the computer vision starts getting really, really interesting. So make sure you watch our next video also. Thank you.